10:30, it ended at 12:15. It was two different tests. We got 90 minutes at least one. And I think
Well, it looks like it's just fourth bit.
Oh, wow. That didn't even dawn on me. It's only right now we only have people from grade 4, 5.
I think some other guys are coming. They're going to have to start at 2.
What? So did you guys do the ratio test problems? Oh, okay.
Yeah, I was going to wait and then come in tomorrow and do these. But then I was like, I'm just going to go.
Because that's what we're going to go over these.
Yeah.
So. How's it going, Danny? Good.
What's up? Yeah, it is. Yeah, because they don't think it's no, they don't have to. They just did the 20 tables. Oh my god. Yeah, I think
I actually consider this one. It's like the first time that
yeah.
Why would you do tonight if you're coming today?
Yeah, I think so. Are you doing that? Probably. Are you doing Tuesday? I think so. Yeah. Oh, yeah. Yeah, I know. Yeah. Yeah, and I'll do it again tomorrow.
Do number 7 on the first section of this, because I don't know how to do that.
Yeah.
You know, my whole fourth period, grade 4 or 5 classes here, except 2 people. Right? 2 classes?
Yeah.
I think I got the whole thing here now. That's better. I guess from here it kind of did look like control. That's funny.
That's funny, though. Is this your biggest class?
What do you mean?
No, like, they're getting stuff.
Yeah, I feel
Oh, you guys want
pretty.
No?
Yeah.
Yeah.
Yeah. I'll go ahead and. Wait,
I don't know.
Yes, we will. Oh, I do not want that back. I did so bad.
Wait,
Yeah, they're in there. I get it. That doesn't mean that 100%.
No,
It could be literally anything. It just means you're. You got like a 16
Got like a.
You guys are all out.
Oh, the boy check that I got.
Leave, you don't.
I just saw my grade
Quit.
drop.
Just quit, Joe.
I'm honestly thinking about it. Should do that.
What do you guys have today for your workout?
Easy run? I got a 15 out of 20. Yikes, bro. I just went 0 for the last one.
Oh, I guess. Oh,
I don't know.
actually. Yes.
Wait, he put 2 at first, and then he changed it to a 3.
Or you put 3 first, so it takes it to 2.
I mean, yeah. But he gave me -5.
Okay.
So, it gave me 3.
Maybe he was just like,
You know, I kind of hate this guy. I'm going to drop him at this point.
I don't like this guy.
Wait, not all, but like, there's like 3 best.
No. We have like a whole row of things in more.
Yeah, he said this is like all your class.
You can just say this one compared to that one. And that's it.
Billy, that's literally the comparison test.
Oh, Billy.
What did you get?
Yeah, you said
Billy, literally comparison.
This one compared to this one? You just say that? No. Gavin? Yeah. How do you Gavin do better?
I don't know, but
That's why. What? Gavin, can I see it? You get
Probably my right show you one.
What if the address is 7 I got it. 1 over square. You're an idiot. Okay, so here, let's talk about these. The number one miss problem on this was the number one miss one on this was number 2. So, which I found interesting, and a lot of people miss number 2, and I don't think it was the calculus that caused problem. So, this was the problem, yeah, which is equivalent to this. Right? You can almost pick any P-series you want. Like, this is so less than just about everything that you can think of that converges. Like, the entire 1 over n squared. This is way less than that, right? Because e to the n so big. I mean, 1 over e to the n converges by himself. So 1 over e to the n times n squared is certainly going to. So I just did a direct comparison test for that one. Number 1 was converging. I used a limit comparison test. You could also use a direct comparison test. Either one. They all converge, actually. I don't know if you guys realize that, but every one of them converge. Number 3. This is probably best use of the integral test. I mean, you don't have to use the integral test, but that's what I chose to use. When you do the integral test, you end up getting this, because it's a u sub, you end up getting 1 over u squared. And then once you're there, you know that converges because that's a p integral. 4 converges. I did a limit comparison with 1 over n squared. 5 converges. I did a limit comparison with the geometric series. So this one, actually a direct comparison is probably easier because you could say this is true, right? But if you do a limit comparison with 1 over 3 to the n, you get this. A few folks had that, and then they struggled with that limit. The answer to this limit is actually 1. Because this is balanced in 3 to the n. This is like 1 3 to the n and 1 3 to the n. Number 6 is absolute converging. It converges when it alternates, and then when you take the absolute value of the terms, you actually have the series from number 1. How many of you realize that? Like, okay, I wasn't, because most people did it again. And I just was curious, did they realize that was the same problem? Or, sometimes you just, stuff like that gets away from it. And then the last one, this one was kind of commonly missed. So the series looks like this, the way I have it written, which is equivalent to this. Yes? Which is equivalent to this. The common ratio is actually 1 over e squared, not 1 over e. Yeah. What do you mean? You mean like this? Then it's not geometric. Yeah. So, well, it's still geometric, but the common ratio is 1 over e squared, not 1 over e. Because of that. Yeah. The same rule applies, but the common ratio is, even when it's written like that, it's a geometric series, but the common ratio is 1 over e squared, not 1 over e. Yeah, right, because the common ratio is 1 over e squared. Like, no matter which way you write it, you're thinking this, Samuel, because like it's written like this, that the common ratio is 1 over e, but it's not. This is still a geometric series. It's just not written. This is how we would write it as a geometric series, like the form. Just because we changed the form of it doesn't mean that it's, I mean, it was geometric when it was up here, right? In order to use the formula, it's 1 over, or the first term over 1 minus the common ratio. The common ratio is 1 over e squared no matter which way we write it. That make sense? Yeah.
Okay, so for the integral test, like the number 3 where you use the integral test.
Yeah.
You did it where you have the integral of 1 over e squared, and then you know it converges to the t series.
The integral.
Yeah.
Yeah.
But it's still under the integral. You don't have to finish solving the integral.
Well, if the integral converges, the series converges.
Oh yeah, okay.
If the integral diverges, the series diverges. So, like, the answer to the integral is going to be the answer to the series. Make sense? So, there you go. That's that. So I was playing around with your test this morning while I was giving the air test, trying to come up with a good format. I was debating doing it online. Then I think I threw that out the window. I had one that I actually did last year. We made an online test for this last year during the stay at home day. It's a really good test. Really good. But I don't think we're going to do that. I think we're just going to do, like, I'm going to give you a series, you're going to tell me if converges to what type of use. Nice. And we look at those and then, yeah. Questions?
Yeah, so if you give us a series, do we have to use a certain test? So we could use theoretically the same test every time. Like if we want.
Theoretically.
Yeah.
No, actually, that's not true. Because some of them won't work on some series. I guess I could, and I'm not done making this up yet. I'll be done making it up by Thursday. I'm giving more details in, but I could say, like, use the ratio test. Like, use the interval test. Yeah. So, speaking of the ratio test, how did that go? Did we do the ratio test? So what I wanted to do was go over all of these with you guys, answer questions about them. Just because I wasn't sure if I would have just made a video of this and had no interaction with you, I wasn't sure like your questions would necessarily get answered before in time. Like I didn't want you guys to just be learning, getting comfortable with ratio tests on Thursday. When you have a test on Friday. That would be bad. So, and there's some tricky algebra with them. Right? Let me pull out my ratio. So, do you want to just work out these 8 at the top together? Feel good about that? What did you get for number 1? I didn't hear you say. I'm just hurting birds. It could be anything. Is it die or con? Die. I agree. It's die. Okay. So here we go. N factorial over e to the n. So hopefully you guys are comfortable doing this. Just multiplying by the reciprocal of the nth term. I find that to be so much easier. So then we clean. And what's left here is going to be a 1/3. And n plus 1 factorial over n factorial is just going to be n plus 1. So that's what you end up getting after all of the simplifying. And what's that limit? What is it? Infinity. Everybody getting there? Don't everybody be afraid to speak up. That's greater than 1, definitely, right? So this diverges. Now again, it's important for us to understand what that infinity means. Like not just that, like, oh, we got that number, we got that answer, and we can use that and make the conclusion. What does the infinity mean? It means that the ratio of the terms is getting bigger and bigger and bigger. Like as you go from term to term, it's like you're multiplying by a bigger and bigger number each term. Like the terms are just getting monstrosely huge. Okay? Number 2. What did we get for this one? Conflict is good. So ready? So we're going to do the n plus 1 term divided by the reciprocal, or divided by the n term, I guess. I don't need to multiply by the reciprocal. I could if I wanted to. So we happy with that? Now what happens to the 3/4? 3/4 to the n, 3/4 to the n plus 1. This gives us a 3/4. You can leave the 3/4 right here if you want. So as n goes to infinity, what's this limit? Well, the part with the n in it, this part's going to 1, but we have times 3/4. So this is 3/4, which is less than 1. So what does this guy do? He's a converger. What's the matter?
Billy said I suck.
Really?
I think it's good.
That's not nice.
Come on, Billy. Quick.
What about number 3? Billy, did you get that one right?
Nope.
I don't hear y'all saying that you suck.
That's all right, Billy. Okay, you didn't do it.
This one's almost identical to the one we just did. But what's the difference? What's this limit going to end up being? 3/2, right?
Yeah.
Which is greater than 1, so he's a diverger. These only get crazy when there's factorials involved, don't they? That's where they get scary. Let's do 4 right here. So let's set up the ratio test. The n plus 1 term times the reciprocal of the nth term. Yep. So after we clean up, what happens with the 2's? What are we going to get? Just a single 2 in the denominator, yeah? You can also take that 2 and pull it outside there. It's totally okay to do this. In fact, you might even argue it's better. But what's the answer to the limit? When we're all said and done. It's 1/2, yeah? Which is less than 1. Converges. Okay, what about number 5? What do we think? Bless you. What's number 5 do?
Converge.
Converges? How many think that? How many agree with that? Billy, do you agree? I think number 5, did we do number 5 in class? Did we do that one like that? I know we did one like this in class. It was odd powers, wasn't it? I think it was odds. Like, it wasn't it 2n plus 1?
Yeah.
Yeah. Okay. So here we go. -1 to the n plus 1, 2 to the n plus 1, over n plus 1 factorial. And then we're going to multiply by the reciprocal of the nth term. N factorial over negative 1 to the n to the n. Okay? So the first thing we're going to do is, like, we can clean this up big time. The absolute value lets you chuck the negative 1. All right? I don't want you chucking the negative 1 before, though. Like, I want you to set up the ratio test, like, this way, and then chuck it. Okay? So don't try to cut a corner there. So this we can chuck. What about the 2's? 2 to the n plus 1, 2 to the n. You subtract the exponents, you're left with 2 to the 1, right? And I'm going to go ahead and do this because this is still confusing for kids. So now I have to simplify n factorial over n plus 1 factorial. So that's, I'm going to pull the 2 out. N factorial is just n factorial, but n plus 1 factorial is n plus 1 times n factorial. So those guys cancel. And now you're left with 2 times the limit as n goes to infinity of 1 over n plus 1. And what's this going to end up being? Even after you multiply by the 2. 0. Yeah? Because it's 2 times 0. So that's 0, which is definitely less than 1. Right? So what do they do? Piece of converger. I'm not sure why I just identify all these T's. Mix it up. There's something I was going to ask you. Oh, I know what it was. When you're doing that limit, what happens if you get a negative? Is that less than 1? Would it converge? What? Yeah. You won't get a negative when you do that. Like when you're doing the ratio test, you will never get a negative number. If you did, you done messed up. Okay? 7 and 8 are, number 7 is really the scary one, isn't it? 7 is super scary. Okay? So we're going to do limit as n plus 1 term with n term, yeah? So here we go. N plus 1 factorial. N plus 1, 3 to the n, n, 3 to the n, over n factorial. You got the n plus 1. Say what? 3 to the n. Oh. Thanks. Now it might be tempting. It might be tempting to sort of want to cancel something here. Okay? First thing we have to understand is n plus 1 factorial over n plus 1 does not equal that. Right? You agree? So I would try to keep, when you're canceling and simplifying, I would try to keep the factorial things together and the non-factorial things together, because you're less likely to make a mistake. So how does n plus 1 factorial n factorial? How does that simplify? N plus 1. Now, my friends, these guys could cancel, and you're left with n 3 to the n and 3 to the n plus 1 just ends up as n over 3.
And what's that limit? Careful, it's not 1/3. It's real tempting to want to make that 1/3 just because it looks so cute with that 3 underneath.
Okay, what is this limit? Infinity, which is definitely bigger than 1. So this is a diverger. And then number 8 or 7. If you can do number 7, honestly, if you can do number 7, you could probably do any of these. I mean, if you can algebraically get that and have it all worked out, you could probably do any of the ones involving your ratio test. Here we go. So the n plus 1 term and I'm going to write n plus 1 factorial squared like that. Over that times the reciprocal of the nth term and I'm going to write n factorial squared as n factorial times n factorial. I think the algebra is a little easier to see. Okay. So that's going to be 3n plus 3 factorial. Whew. Okay, we're going to write out all the steps here so we see it. In the numerator, n plus 1 factorial is the same as n plus 1 times n factorial. N plus 1 factorial is the same as n plus 1 times n factorial. And then 3n factorial is just 3n factorial. Okay, what's the denominator?
3n plus 3 times 3n plus 2 times 3n plus 1 times 3n factorial.
Yeah, 3n plus 3 times 3n plus 2 times 3n plus 1 times 3n factorial. What? Oh yeah, I'm not done. Times n factorial. Times n factorial. Okay, lots of canceling here. So n factorial, n factorial, 3n factorial. I think that's everything. So here's what we left with. N plus 1 times n plus 1 over 3n plus 3, 3n plus 2, 3n plus 1. Whew. It's like they're way up there. What does that equal? What's that limit? 0. So all that work gives us 0, which is less than 1. So he converges. Yeah.
Could you also just like put everything inside the squares and then solve it that way?
Say that again.
Could you put everything inside the squares until like
Yeah, you could have done it that way. Yeah, I actually did it that way just to write it all out so people can see the canceling. It's easier to, I feel like it's easier for folks to see the simplifying when it's all like this rather than using powers of exponents or properties of exponents. Like, I think there are still some folks that are like struggling with why that's 1/3. Like, I mean, we shouldn't be, but some of us definitely are. So, like, when you have all this factorial stuff in there with them squared, I feel like that's even more intimidating. So, but yeah, it's totally legit. Questions? Other questions? How many did that one right? Yeah.
When you say the ratio of the terms approaches zero, what does that even mean?
If the ratio of the terms is approaching zero, how can I explain that? It means that if we're thinking about a line of terms, so this one's further along than this one, the ratio is this divided by this, right? Like when we're saying the ratio of the terms, it's this one over this one, the n plus 1th over the nth term, the 7th over the 6th, the 197th over the 196th, you know what I mean? Yeah. If the ratio is approaching zero, that means this guy is approaching zero at a much faster rate than this guy is. And so if he's approaching zero at a faster rate than this one is, this over this is going to approach zero eventually.
So why does that mean it's convergent?
Because all the ratio test tells us that as long as the ratio of this to this is less than 1, it converges. Does that make sense?
Mm-hmm.
Can't read your face. No, doesn't make.
I mean, like, but why one? Like why is it? What is
Well, it's got to be less than 1.
Yeah.
So, I mean, it's essentially just, I mean, it's what the geometric series is, right? You know, this series here, 1/2, 1/4, 1/8 plus 1/16 plus 1/32, yada, 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 right? The common ratio, like this divided by this, this divided by this, this divided by this, this divided by this, that common ratio is 1/2, right? As long as the successive terms, 1 divided by the previous one, is always, if that ratio is less than 1, when we're geometric, it converges. What the ratio test basically just says is, okay, this has to, in order for it to be geometric, it has to be true for every single term that has a common ratio. What the ratio test does is basically just says, well, we don't really care what's going on down here, but if way out here, if the ratio of the terms is approaching something less than 1 and it's looking like it's geometric, then it's going to converge. Like, it doesn't have to actually be geometric, it just has to sort of behave like geometric way out there. Like, we don't care about, you know, oh, the first million terms, no big deal, but way beyond that, if it's looking geometric, then it's going to behave like a geometric field. That's kind of the gist.
Is that why, like, when it equals 1, like the ratio, it's just basically the same?
That's why the test fails. Yeah. When this limit equals 1, the ratio test fails. Because what that's saying at that point is that the terms are basically approaching the same number.
Mm-hmm.
It still could converge as long as those terms were approaching 0. Does that make sense? Mm-hmm. So, I don't know that we've seen one where the ratio test failed. I don't think we have seen one. And I'm not sure I could come up with one off the top of my head. I have to look. look that up. Do you want the answers for the bottom ones?
Yeah.
Oh, we didn't do 8 yet. Why is it? What's the answer to 8? You don't even have to use the ratio test.
Divergence.
It diverges. Why?
Or bigger.
The nth term test. That the terms are approaching infinity there. Okay. But let's go ahead and do the ratio test just so you can see it worked out.
So the one where it failed, it's -1 to the n over n. Or sorry, yeah, -1 to the n over n.
The alternating harmonic?
Yeah.
Oh. I should have known that. You're right. So here we go. The ratio test. Okay, careful that this is 3 to the n plus 1 plus 1. Times the reciprocal of the nth term. So what we got here? We've got a 4, right? That's going to be the limit as n goes to infinity of 4 times 3 to the n over 3 to the n plus 1 plus 1. Yes?
There's a 1 missing, right? Everybody like that reciprocal?
Say what? 3n plus.
Oh. Thank you. That right there?
Yeah.
Eliminate that right there. Okay. Now, I'm wondering how many of us know the answer to this limit or would have just faked it. What is the answer to this limit? How many of you think it's 4?
How would we take that?
Well, faking it because you knew it would diverge, and so you were just gonna be like, "Oh, that's less than 1," and just kind of, weasel your way through there. We've all been there. We've all done that.
Mm-hmm.
What is the answer to the limit? 5/3? Say 5/3?
Yeah.
I think I know how you got to 5. The answer to the limit is actually 4/3. Okay? Now, why is it 4/3? Technically, the way this is written right now, it's not in the balanced form. Because the power here is 3 to the n and 3 to the n plus 1. But you can make it balanced. Because 3 to the n plus 1 is the same as 3 times 3 to the n. 3 to the 1 times 3 to the n. Right? And then, just because Colin got 5/3, I want to show him why it's not 5/3. Okay, so you see what I did there? I just distributed the 4 in the numerator. Now it looks kind of weird, but now it's quote unquote balanced. It's balanced in 3 to the n. What's the coefficients? 4 and 3. Right? Technically, the balance thing works because of L'Hopital's rule. If we were going to use L'Hopital's rule and actually work it out, we'd say, oh, the derivative of the top is 4 times 3 to the n times the natural log of 3. And the derivative at the bottom is 3 times 3 to the n times the natural log of 3. And those guys will cancel, and that's how you're left with 4/3. Okay? I think, did you get the 5 because of that 1 there? Yeah, that 1 turns out to be insignificant.
Yeah.
So what about the bottom? Do you want the answers? So the alternating harmonic series, -1 to the n over n, the ratio test fails on that. I forgot. I mean, that comes up all the time. I don't know why I didn't think of it.
That's like the first thing.
What's that?
That's like one of the first things.
I know, but I didn't show you that the ratio test failed. But the alternating harmonic series comes up all the time when we're studying power series. Like, and I just don't know why I didn't think of that. Yeah.
So when the ratio test fails in the equation, not absolutely convergent, like if you take the, or like not absolutely convergent or invergent. So like,
Would the ratio test fail?
like any, I'm blanking on the word, it's like it's
Conditional?
conditional, any conditional equation, wouldn't it fail always?
Yes. Yeah, and I don't mean like I'm an idiot for thinking. Like I don't know why.
That's the same.
I mean, it was embarrassing. I should that I didn't know that, or that I didn't think of that. Okay, so what's number 1 at the bottom? That's converging alternating series, right? Now technically that's a conditional, but I didn't ask you that. But I did want to point that out. Okay, what about number 2? That's the diverging. Why? You could just say that's the harmonic series. It's actually 5 times the harmonic series, but in the harmonic series, like everybody knows diverges. I mean, you could ask anybody. I mean, this evening, you know, when you see someone, they say, "Did you know the harmonic series diverge?" Most likely, they're going to say yes. Okay. Yep. Number 3 is a P series that converges. P is 3 halves. Yes. Woohoo! 4. It's geometric. Yeah, that one's geometric and it converges big time because pi over 4 is less than 1. Okay, what about number 5? That diverges by the nth term test. Right, the nth term test on number 5. What are the terms approaching in number 5? 2. Number 6. That diverges. I would do like a limit comparison test with 1 over n. That's how I would do it. That's the easiest way to do it. Could do the integral test if you wanted to. Integral test works nicely there, but yeah.
So could you just reduce it so 1 over n is the harmonic series?
Okay, so when you reduce it, you're saying, oh, that reduces to 1 over n, and I know that diverges. Like, you just don't want to say that equals 1 over n, because it doesn't. Like, what you're doing there when you reduce it is the limit comparison test. So, like, if I ask you to work it out, you need to make sure you know how to work out the limit comparison test. But you definitely can just know the answer. Now, where is that beneficial? When you're testing for conditional or absolute. Or, if, like, say on the test, I give you a section where it's like, does this converge or diverge? And you don't have to show me work. You just, boom. But I'm actually thinking about putting a section on the test where I just give you, like, series, and you just choose converge or diverge. Series, converge or diverge. 50-50.
So
I will be honest, the thought went through my head of giving you, like, 40 of those. Like, where it's just converge or diverge.
That should be all.
It, like, just, that was going to be the whole test.
Yeah.
Like
40 though? That's a lot.
40 was an arbitrary number. I mean, it would be a doable amount in the time period. Because so many, once you really understand it, so many of them you can do in your head. Like once you get it. Okay. What about number 7? He converges, that's a P series. I mean, the 10 thirds is stupid. P is 3 halves, by the way. Number 8, he diverges by the nth term test. What are the terms approaching in number 8? Be careful. I mean, essentially, I'm asking you, what's the answer to this problem? The limit as n goes to infinity up to the n over 4n squared plus minus 1. What's the answer to that problem? It's infinity, right? That's big time top heavy. That's infinity. So the terms are going to infinity.
Shut up.
I really like number 9. Number 9 is my favorite one in the bottom. You hate it, Billy?
Anything like trig. Whenever you throw trig in there.
Anything with the S,
The number SIN.
I hate that number.
So you love that series, right?
Yeah.
Now, the thing I need to ask you, the thing that's going to give you insight into understanding how this problem works. What do you know? This is a little question. What do you know about the cosine function?
It's restricted, or what do you want to boundary?
Its range? Yeah. I think that's what you're trying to tell me. Yeah. Its range is restricted to what? Oh, yes. Yeah, that's actually true.
I said that before.
Why didn't hear you? I didn't. He raised his hand. You said bounded?
We both said it. I said
Bounded between 1 and what? Between negative 1 and 1. Okay? So,
That's like alternating series.
well,
Not like
it's kind of, it's not alternating because that's cosine of n, not cosine of n pi. Okay? So that numerator is not always going to be 1 or negative 1. It's going to be something between 1 and negative 1. Right? But if that's true, if this numerator is always between 1 and negative 1, is it fair and obvious to say that this is true?
Yeah.
Think about that for a second.
Yeah, that's true.
If the numerator is always between 1 and negative 1, you're basically saying some multiple of between 1 and negative 1 times 1 over 2 to the n. Guess what? That's going to always be less than 1 over 2 to the n. And what does 1 over 2 to the n do? That converges to the geometry. So that guy converges by the direct comparison. That's like a big boy direct comparison.
So you can't say, that it converts by alternating series step.
No, because that's technically not an alternating series. Yeah. No, it would be alternating, Samuel, if that was cosine of n pi. Right? Are you guys playing footsie over here? What are you doing here?
No, I'm trying to get pencil. I'm just trying to help a friend out.
How many times have I had to say old Billy? 4? It's just like the judge. If the judge have a higher days going, and how many old Billies there was. You have a question, Holland?
Yeah, you can do it by the M term test too, right? No.
Because the nth term test can only tell you that a series diverges. Okay. Number 10. It has an integral smell to it.
It does.
Okay?
I was like in.
But I'm sure a lot of you are like, if I can avoid using the integral test, I'm going to avoid it at all costs. Okay? So did anybody do something different? Like, did anybody do anything different? So everybody did the integral test?
I didn't do
Or you didn't do it? You skipped it?
Yeah, I just did the first section, focus on that. And that's it. I would use the integral test though.
You want to do the integral test?
Do you sub, right?
It's not a U sub. Is it?
I don't know.
Is this a U sub, Hip?
U sub? I would say no. I haven't looked at it in a while.
Okay.
I haven't looked at it in 35 years.
Longer?
I
It's not a U sub. How do you do that? By parts.
Oh, yeah, never mind.
So now you're backing off like, screw the integral test.
No.
Well, let's do it. How do we do this by parts?
Oh, it's like the
There's a phrase I would say.
times v minus v times t.
the integral one.
Well, you're telling me the formula. I'm assuming that we know the formula. Like we're trying to set up the we're trying to set up the U's and the DV's. And I always say, who makes great U's? Natural logs make great U's. Right? Natural logs make great U's. So U is natural log of x. dv is x to the negative 2. du is 1 over x. v is negative x to the negative 1. So that's natural log of x over x minus negative 1 over x squared dx.
Would be over. I didn't know it was gonna finish with this.
Yeah, I think the integral test is really the only one that works on this one.
I think all the other tests don't seem to work. I tried like every other test.
Oh, yeah. That's smart, yeah. No, with the integral test.
I think this was from 2 to infinity, right?
One.
Okay. Doesn't matter a whole lot, but- So as we're looking at this now, I've got the natural log of infinity over infinity plus 1 over infinity, right? Minus something that's constant, natural log of 1 over 1 plus 1 over 1. Like this part's, we're not worried about this part right here. We're worried about this part right here. Is this approaching infinity or not?
Wouldn't it be?
Well, this is approaching 0, right? So this is approaching 0. What about natural log of x over x? Now I feel like we've dealt with that enough times now that we know what happens to that. What happens to natural log of x over x? It approaches, as x goes to infinity, that's going to approach 0. Because x is actually bigger, isn't it? X is dominating natural log of x. So that's technically bottom heavy. So this is approaching 0. So this converges. So the series converges.
I don't like that one.
You don't like that one?
No.
Well, put that one on the test then.
No. Oh, yeah, because it's that exact same way. Then, yeah.
And what about the last one? That one converges.
Ratio.
Which test are you going to use on that?
Ratio.
The ratio test. So we figured out the ratio test is the one you want to use when you have a factorial in it. So we figured that out.
Yep.
I mean, if if you chose ratio on that last one, I think you did figure it out.
Could you just do the alternating?
Oh, actually, I think you're right, because, yeah, that one, you could say it's alternating, but it's absolute. Yeah, that one is alternating, but it's absolute, so. I didn't technically ask you whether or not it's absolute. Well, that was a lot of fun.
That's pretty good.
So now you guys have this down, the ratio test down. You can study the other tests. Yep. On Thursday, we can maybe even start talking about power series, just have a little game of power series. Maybe not.
Yeah, focus on the test. We get to this one first.
How did our Delta math go?
Oh, that was good. Good question.
Not everybody did it, but I didn't, some people did. You think that helped you?
Yeah.
You want to do another one?
That was for a grade, right?
Yeah. That was for a grade? I didn't say I was going to, so there's people that did it. I'm glad I did it. Glad you did it.
Thank you. I'm glad I did it.
And
Can you do one for points? I'm struggling.
There's two grades in the
I know.
Yeah, you only have 2 grades so far.
I mean, like,
He's struggling already.
Well, this quarter's cut real short.
Yeah, but we're gonna have to come in.
I mean, you gotta think about it.
A month.
No.
Are you still having the final exam like the day before we graduate?
And that's not a month. That's like,
Okay.
and, I might even be able to do it so you don't even have to come in all those days.
It's a day before.
What?
We graduate the 20th. It's the 20th.
Oh, you mean a month from now. It's not a month extra.
Oh, yeah.
It's like a week and 3 days. So a week and a half.
This should be a class.
Yeah, can Abdel come to our class instead?
You
I'll
have
miss
room.
you.
You have room.
Kevin, what do you mean? I would miss it. I wouldn't miss it. I'll literally be in the next class. Yeah, thank you. I miss you. I'm like on that one. Well, that's actually what's called a binomial distribution. So you can calculate probabilities, like what's the probability you get at least 30 of those right?
Yeah, then that would be 5, like 32 over 30.
It's called binomial distribution. But
42, 30.
you have a question for me?
Yes, I do. So for the ratio test, you can use it like for any of them?
You can use the ratio
For like all of them,
for most
except
of
if,
them.
yeah, most
But,
of them, and it
like,
doesn't work.
It didn't work on this one.
Yeah,
Like if you use the ratio test on this one, you would have gotten it.
yeah,
So you got one. Why did you say, oh, there's
Oh,
one
I
that?
didn't- no, I didn't use that.
Why
I
did you
used
say
the
that? When I was like, I
ratio
can't
test
figure
for
out.
that. No,
Yeah,
I just
I'm
did
pretty
that.
sure you get one on this if you do ratio test.
Unless there's like an easier one. like
The limit
something.
comparison test, like if you do that on this one, if you use 1 over n squared, you get you get 0,
Mhm.
I think, and so that doesn't work. So like the only thing that worked on this one was the integral test.
Yeah,
So sometimes like the ratio test won't work, but it pretty much works on most of them.
Yeah.
But it's also, though, Carrie, it's not necessarily the best one to
Yeah.
use because like
yeah.
You know-
If you,
like this one, like the ratio test would have been much harder on this one because you would have had to, you would
Yeah,
have had
do it
cosine of n plus 1 over 2 to the n plus 1, and then you would have ended up with this.
yeah, I think.
And then you would have had a 2 there, and you would have had to know what that does. Like, that doesn't help. It's so much easier just to think through.
Okay. Alrighty, see you Thursday.
See ya.
Oh, yeah, I tried every single test on that one, except for interval test, so if they want to do integral.